I wanted to go over this worksheet for those that still had questions about it. This is a positive correlation. Correlation meaning the way the points are related. Correlation. The correlation of these points would be a positive correlation, because if I went ahead and drew a trend line for these dots, it would be in the middle of it like that, so that I could predict at a certain point. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. In a perfect world, let's just say that this is drawn to scale. And as you can see, my prediction would be 5, 6, or excuse me, 5, 5. That's a positive correlation. And the trend line. The trend line also points up, so it helps me to see that my positive correlation is pointing up. And this is a negative correlation because it's pointing down. So I know if I draw my trend line down the middle, I see my line pointing down. I can also predict using this. Say that's 3. That's 10. And as you can see, my prediction would be 3, 8 for that. And this is a negative correlation. The word correlation meaning how the points are related, and it's a negative relationship. Here, there's no correlation, no trend line. So I can't predict because this is information that's not related. Like the length of your hair and the size of your foot. If you get a haircut, your feet don't shrink. It's not related. Now, positive correlations can increase and increase, or decrease and decrease. Negative correlations can increase and decrease at the same time. No correlations do none of that. They're not related. So we look at number 1. The number of cigarettes you smoke and the years you're expected to live. The number of cigarettes is what you can control, so that is your independent. The years you're expected to live, you won't know that until after you know how many cigarettes you're smoking. So that's your result. That's the dependent variable. So now we're going to go to the table and figure out, what do I label the first column, what do I label the second column? Well, if this is X and this is Y, and we know that X is independent because on the X-axis hangs the I. Well, for no correlation, you're not going to have independent or dependent because it's not related. Either both statements are independent or both statements are dependent. For this one, I can't say I or D because it doesn't apply to the no correlation. It only applies to these two. So since the X-axis hangs the I know the statement for X is an independent. That means number of cigarettes. For dependent, that's the Y-axis. Sits the D on the Y-axis. So I know that Y is dependent. So this is going to be the years expected to live. I want to remove this 4, 5 down and give us a starting point. So at 0, we're going to say 15, you expected to live 15 extra years because you do not smoke at all. So in 4 years, you're expected to lose 4 cigarettes, 4 cigarettes. Let's say 4 cigarettes a minute. You're going to lose 10 years of that extra 15 years. If you increase that to 10 cigarettes a minute, let's say you're going to lose an additional 2 years. And then if you, for another person, they're doing, let's do 15 cigarettes in a minute, which means there's a lot of smoking. They're going to be down to that 1 year. So they've lost 14 years of extra expansion of their life. Now we look at the table to see, is this positive or negative? Is this a positive or negative situation? Well, as you smoke more, your years that you're expected to live decreases. And I'm calling it extra years just because that's what I'm calling it. You can say that if you're at the age of 65, you have 15 more years to live, but if you smoke 4 cigarettes a minute, then you're going to only have 5 more years to live. So the question now is, does this table increase and decrease at the same time? Increase, decrease. Yes, it does. Which correlation does that? The negative correlation does. So this is a negative correlation. And if we wanted to predict at 10, I've already 3, 4, 5, 6, 7, 8, 9, 10. I've already drawn my trend line. And at 10, it looks like it's at 2. We'll do the next one. The amount of shoes you buy versus the color of the shoelaces. Well, that doesn't depend on each other at all. Because if you buy 30 shoes, does that mean they're going to be black or green or red shoelaces? No. So it doesn't matter. You can put the amount here and the color here. You could put the color here or the amount here. It doesn't matter. So what would the table look like? Well, the points would be everywhere. They're just information. It just doesn't matter. And as you can notice, there's no pattern. This doesn't go up, this go up, and this go down, that go down. It just doesn't matter. No predictions, no trend line. Excuse me. No trend line, no predictions. This is what the table looks like. It's just scattered everywhere. So I decided to put color here on the x-axis and the amount on the y-axis, which means I need to go back to number 1 and fill in the x and y-axis for the negative correlation. So the number of cigarettes is independent and the years is dependent. And now we can do number 3. I'm going to change this to responsibility. The responsibility you have and the amount of extracurricular activities you're in. Which one is independent and which one is dependent? Well, if I'm in a lot of activities, then I'm going to have a lot of responsibility. If I'm in a small amount of extracurricular activities, then I'm not going to have as much responsibility. It would decrease. So as my independent increases, my dependent would also increase. Meaning my extracurricular activities, as they increase, my responsibility goes up. So you're in band, you're in choir, you're in football, you're in reading club, you're in the step team, and you're the president in all of those clubs. You're going to have a lot of responsibility because you're in a lot of clubs. Now, if you're not in so many, what's going to happen to the responsibility? Or if you get out of 2 or 3 of those clubs, what happens? Your responsibility goes down. So when you decrease your activities, the responsibility goes down. That is what a positive correlation looks like. Positive correlation just means that they follow the same pattern. Either both go up, both go down. For those that say, no, this should be negative, remember, a negative times a negative is a positive. For instance, negative 2 times negative 5 is a positive 10. So this negative and this negative going down, that's going to still give me a positive correlation. Now I look at my table, and since the independent is X, that means extra activities go here, extracurricular activities, and responsibility goes here. And remember we said that they would both increase or both decrease, so I'm going to cause this to increase. 1, 4, that's increasing, 7, 9. And it's a scatter plot, so they're not going to have set pattern, which is okay because they're scattered. Now there is a case where they are evenly written down, the points, and that happens, but most of the time they're scattered everywhere like this. And so it wants me to predict at 2, so let's do that. At 2, it looks like I am at 3. So what does this point mean? Well, X stands for extracurricular activities. So when I am in 2 extracurricular activities, I'm going to have maybe 3 times as much responsibility than I would if I were in none. Okay, let's look at this one. What does this point mean? Well, X is the number of cigarettes, 2 is the number of years. So depending on what I want to call X and Y, X could be if I do 10 cigarettes in a week, then I can expect to live only 2 more years. That could mean if I do 10 cigarettes in a minute, then I'm only going to have 2 years left of extra living time. If I thought I was going to have 15 extra years, I only now have 2. It just depends on what you set your X and Y to actually mean, to know what the point means.